Ladies and gentlemen, thank you for being with us. We have on stage Yonatan talking about GitHub Actions. Take it away.
Good. Hi. Can everyone hear me? Yay. Good afternoon. It's a pleasure to be here. Thank you for having me here and coming to my session. Okay, I'll tell you a story until everyone is seated. So not many people know this about me, but I used to be a neuroscientist up until 2014. I was working with barn owls, researching their auditory and visual system. And my wife also has a PhD in neuroscience. And in 2014, we got to this situation in which this is how our refrigerator looked like, and our bank account didn't look much better, by the way. So we had to do like paper, scissors, you know the game? Who's going to hunt for food and who stays in science? I lost. And yes, I was doomed to do JavaScript from then on for food. Yeah, we're here. Okay, so talking about food. I really love food. Probably can see that. Actually, I'm a runner. I'm running long distances, and I eat a lot just to make up for my hobby. But any of you made food, cooked at some point? Yeah, a few of you. Nice. Hardworking people. So sometimes it goes out pretty well. Sometimes you can be like Homer and burn the cornflakes. But I'll tell you about chefs, how chefs work. Chefs, they don't do the food on their own most of the time. They teach people how to do it. They take any person. They tell him you put this amount of salt, this amount of pepper, this amount of whatnot. You put it like this, or like this, or like this, and like this, whatever. And every time you go to a chef restaurant, you get the same dish if you order the same thing. Okay, because they train the people very well. But it's costly, it's not efficient, and there is a very big churn in kitchen workers. So a friend of mine invented something really cool. It's called Bistro by Kitchen Robotics. I'll turn it on. Probably won't hear, but can you hear? Doesn't matter. Yeah. So it's an automated kitchen, autonomous kitchen, if you want to be high-techy. A chef goes to the place, starts telling the machine what to do. Sorry, just turn this off. Tells the machine what to do instead of telling the person. Tastes the dish, and then fixes what needs to be fixing until the chef is satisfied. And from then on, when you get into the restaurant or the mess hall and you order the food, you get the exact same dish. So yeah, I was excited about this and about the fact that it also washes the dishes. So it's a really cool thing, and I know the guy who invented it personally. And I'm talking to you about this because we're going to talk about automation. Okay, automation in software, more precisely. By the way, this kitchen can't make coffee, so not really worth your money. So automation in software. I think most automation in software revolves around things called CICD, continuous integration, continuous deployment, which are our way to work in teams and deploy our product faster. We'll see how to do it and how to optimize it, because it's a very important factor in automation. And we'll see some things beyond just deploying your software. So on every workshop I do about GitHub Actions, I run a survey around between the attendees, and I get these results. Like, everyone tells me what it thinks or what she thinks about automation, what automation means to them. And things come up pretty regularly, like time saving, testing, reliability, and that sort of things. Manual labor, you want to convert manual labor to automated labor, save time again. And these are all true. Okay, the benefits of automation are consistency, you save time, you save money, a lot of frustration is saved, and you speed up the production, the development, and the publish to production. And okay, so I hope you got some motivation to learn automation, and I'm pretty sure most of you have automation in your own projects, but we'll learn how to do it with GitHub Actions. How many of you are using GitHub Actions, by the way? Raise your hands. Wow, a lot. Cool. So yeah, GitHub Actions is relatively new in the world of CICD. I think it's 6 years. Okay, it came out of beta not so long ago, 4 years, I think, something like that. But let's take a look at the CICD process. Okay, this is like a typical CICD process. So it starts with a pull request to your GitHub. Sorry, GitHub is not working with that. And then you run automated processes. Okay, you want to see that the build works. You test, lint, or any other standard you can think of in your team. Okay, even compiled file size or whatever you want to test. If you pass everything, and of course a code review, which is still manual, you merge it to your main branch. And from then on, in a very idealistic world, we start the process of moving to production. So we can do the same steps here for quality tests. Okay, it can be the same process as this one, but it can also be something else, smoke tests or post-deployment tests. You raise a version in some way, usually, and then you deploy. It can be a website, an application, a whole Kubernetes ecosystem, whatever. How does it look on GitHub Actions? Let's take a look at a thing. Okay, this is one of our projects. It's called Vivid. It's just a design system, like a UI components library. Can you see the? Yeah, no, it's big enough, I think. So this is a common flow for a CI. Okay, this is our pull request, and it starts with some optimization we'll learn about, caching the dependencies. Then it does the linting, and then it starts the testing, and it can, in parallel, do the deployment of a demo to our update and some more standards. In this case, it's calling Lighthouse, which is some auditing library by Google. So this is how it looks, and if I'll just run it, so you'll see it is running like this, and if I go to the pull request itself, I think it's deleted because it was already merged. Sorry. But you see it starts running, and you'll see the whole process flowing. We'll see an example for that. And the CD itself, it's pretty much the same. Okay, you have a few steps. In this case, this is the actual release. So I want to build my library. I want to create publishing to GitHub and to NPM. And I also deploy, if I publish succeeded, I want to deploy a new documentation or demo website, for instance. Okay, so how is it done in GitHub Actions? It all starts with a folder called .github/workflows, and inside, any YAML file is being parsed by GitHub or GitHub Actions and starts a flow. Okay, the structure of this file, it's a YAML file, which everyone, I guess, knows, especially if you ever done anything with Docker, for instance. It starts with the name. You have a name for your flow. Trigger, what kind of actions trigger. In this case, any push to a pull request against main, but it can be a lot of other things. Okay, we'll see more examples as we go along. And then the main part is the jobs. Okay, the jobs are actually machines that GitHub Actions raises for your automation. And on every machine, you can run a lot of things, mostly even CLI commands. Okay, locally you run, I don't know, Python something, or well, I don't know, compile something, or npm or yarn or whatever. And you can do the same here. Let's see how it looks like. I'll just increase the size of the font. Okay, so this is our job. It actually starts a new machine. I tell it I want the machine to be Ubuntu. I tell it to check out my code, which is pretty important if I want my code to appear. I want it to set up Node.js, install my dependencies, and just run the test code. Okay, it's very simple. You can probably, each of you can think of a command line or a set of steps for your own project. Probably these steps would be different, but check out, I guess most of you will do. And that's it. From then on, GitHub Actions just takes your YAML files and starts an automation process. And you can do whatever you can do with a command line on an Ubuntu machine. You can also raise a Windows and Mac machine. But just so you know, Mac machines are much more expensive, and their internet connection is much weaker. So keep that in mind if you choose a different machine. We saw the checkout and the setup node steps inside our machine. And these are, call them special steps that are custom actions. Okay, they are pre-made actions that exist in the GitHub Actions marketplace. And I think that almost everything you can think of and anything you need was already created and uploaded to the marketplace. Okay, you can integrate your CICD or any automation with Slack, Jira, TeamCity, I don't know, whatever you're using, AWS, GCP, upload to Heroku, whatever. It's already there. Code coverage, anything. You can search by categories. You can search freely, of course. But the thing is that you shouldn't reinvent the wheel. Okay, if you ever find yourself in a position where you want to write a custom action, first search in this marketplace. So let's see how it looks like in the wild. So I'll just go to my. Okay, so this is a pull request. It passed. Let's just get in here. I'll just rerun all the jobs and go back to the pull request. Hopefully it will work. Yeah. Okay, so I see it's running. I see I have a few checks. Some of them passed, some of them finished and passed, and some of them are running now. Okay, and can anyone see a problem here? I can't see you because of the light, so you can shout out. Anyone? You? Cool. I didn't say it, but he gets a Ferrari because of his good answer. Kidding. If I had one, I would give it to you. What? The Ferrari? Sorry. What he said is that I can merge without my tests passing. Okay, that's my issue. And that's a big problem because we don't want that. We want to protect our code quality. We want it to be a gateway. So the way to do that is to actually go to your repository settings and go to branches. And here you can create branch rules. So I want to protect my main branch. And I have a lot of protection options. For instance, I want to require pull request, or you can even require multiple code review approvals. Let's not do that now. But this is the thing that's related to our code quality. I want status checks to pass. So I go for, let's see if I have this. Okay, and I find the build test that I want to be my quality gateway. And I tell, okay, and I tell GitHub Actions, this has to pass before I can merge. There are very important other important definitions here that help you increase the security of your code. For instance, let's see. Okay, for instance, do not allow bypassing the above settings. It's can probably be very important in regards to security. You can lock branches. You can let's see. Okay, signed commit, for instance. Okay, there is a company here. I forgot its name. I'm sorry. They are, I think they were at the top floor of the venue, and they were doing. Oh no, at the bottom floor. They were doing security. Are doing security, and they brought to my attention the importance of these definitions, because someone can actually use your actions to hack into your code. Okay, or use your actions in a malicious way. So you should put the most protections here to not allow this to people who are not from your organization or people you do not trust to do that. Okay, for instance, there, you can disable actions trigger for people who never committed into your repo. Okay, so just people you know who already passed a code review process once can do that. But let's stay with that. Let's hope I didn't do anything. Okay, so let's stay with that just to see how it works. I'll create. Yes, of course, I have security. Let's hope it'll work. Still not here. Yes, got it. Sorry, internet is slow, and 47. Okay, so now it saved the definitions, and let's go back to my pull request. Let's hope I know what it is. CI custom action. Okay, it all passed, and I can do that, but let's rerun all the jobs. Yeah, sorry. And now we're blocked. Okay. Yeah, it's magic. You can clap your hands. It's magic. It's working. Woo! Thank you, GitHub Actions. This is how you can protect your branch. It's a very important part in actually using GitHub Actions. It's not actually a GitHub Actions code or something, but it's a very important part of it. And you see that because I'm an admin, I can be very malicious myself. So beware of this. Cool. So now we get to I think the most important part of the talk. So if you didn't listen so far, or if you're napping after lunch, this is the part you want to listen to. I'll tell you why. I joined Vonage in 2020, and I started setting up our GitHub Actions automation. And we got a call after 2 months from the guy who's responsible for the GitHub Actions at Vonage, or budget at Vonage, and he told me, okay, your team just used 99% of Vonage's total GitHub Actions minutes, and that's pretty bad. So we actually got this call like every day, and it was annoying. We didn't care, but it was annoying. So we had to optimize our CICD process. And there are two types of optimizations. One is to help developers, okay, to speed up the optimization. So a developer, when a developer pushes to pull request or to once the code to reaches production, the developer doesn't need to wait like 2 hours or 2 days or whatever. And the other thing is to optimize for consuming less GitHub Actions minutes, okay? Because your company would probably pay per GitHub Action minutes. So you can compare it to CPUs in Amazon or whatever. So the first thing was parallelization. Okay, it's actually, let's see the code to be easier with the code. What we can do is just raise a few machines and run separate steps on them in parallel. So it looks kind of like this. So I have this build job, which is one machine, it's just running the build, and I can cache the build and use it later. There's a deploy demo step that runs in parallel, so I don't need the build to wait for deploy demo or the deploy demo to wait for the build. You might actually want to do that in order not to deploy if the build fails. And you can see that lint, test, and end-to-end, they all run in parallel, and they all depend on the build to pass. So the moment I have a passing build, I want to start running the test for that build. And they will all run in parallel, so the developer doesn't need to wait for them to run one after the other. So if this takes 30 seconds, and this takes 40 seconds, and this takes 5 minutes, then okay, we don't need to sum them all up, they just run in parallel. Let's see if I have, do I? Yeah, and this is how it looks like. Okay, so I have three, the E2 ELint and test run in parallel. So as you can see, the code here is quite, I don't know, bloated. Okay, I have all these steps, and I have steps that repeat themselves. I have the checkout repeating itself, setup node repeats itself, and etc., etc. And for this, we can actually use a tool, a strategy in GitHub Actions that is called, wait, not caching, what did I do? Sorry. We can use a metrics for that. You know what? I think I mixed up the steps. Where is it? Oh yeah, there it is. Sorry. We can use a metrics for that. Okay, and this is the job, lint, for instance. I probably should change it to CI. And this is the strategy property, and then I create a matrix of variables, okay, which are kind of a set of arrays. So in this case, I have a few operating systems I want to run my automation on, which is all of them, and node versions, okay? And for you, it can be Java versions or, I don't know, whatever, build versions or flavors of your build. And every time I use metrics dot one of the metrics properties, it raises a new machine for every parameter or variable. So what happens if I also use the node version? Can anyone guess? What? Sorry. Yep. Okay. Another good question. Good answer. Sorry. So yeah, the answer is that it runs the number of jobs it will run is the number of permutations in the metrics. Okay, there is a way to mitigate it with conditions, and we'll soon see some conditions too. Any questions about metrics and parallelization? Yeah, you're right. Okay. The, the the comment here was that the macOS using the macOS is not so efficient, and you're right. I mentioned it. The macOS costs more, and it's slower, and its internet connection is slower. So you also get sometimes you get timeout when you just do install dependencies, which is frustrating. And GitHub makes more money out of it, so I don't think they have any reason to fix it. What? Sorry. Sorry, I couldn't hear. Oh, yeah. Okay, good. So the question was, how do you save money when you run things in parallel? So as I mentioned, there are two ways, like two kinds of optimization. One is for developers and one is for the company. So this is mostly for developers, but it can also help you with saving money for your company. Because let's say we have a really long build process, and the build process repeats itself on every iteration of the metrics. So what you can do is take the build out, okay, do it once, cache it like I showed you in the example, and then just use the cache inside the metrics. Okay, so this is like, we're going to talk about cache pretty soon, but metrics is usually very helpful for developers. Makes your code more readable, and just like using a for loop, for instance, instead of just hard coding every step. Okay, clear? Okay, now this is the step where you're going to save money for your company, so you don't really have to listen. At least with us, because our project got bigger and bigger, we had more and more dependencies, and installing the dependencies just took a lot of time. And in addition, our build became much bigger because we had more components, we had more dependencies to inject into our build, and just took more time. So I started researching the caching mechanism in GitHub Actions. So there are 2.5, at least that I know of. One is the built-in caching. Let's just see it. Okay, which is this. Okay, in this case, I set up the node, and it has a cache for the yarn system. Okay, the setup Java and setup Python and setup Go, they all have a cache property. You'll see it in the documentation. But what happens when you use this, actually the package manager that you're using is saving a global folder from which it's going to take something in the next install. And it helps, sometimes it prevents downloads of certain dependencies, but it's not as efficient as having your node modules of the dependencies inside your project, okay? Because then it doesn't even need to copy the files or verify faraway versions. So, so this is what it does. It saves the global global cache that your package manager is using, and saves you some time, mostly on saves you the download of packages sometimes. But you could do it even tighter, okay? And you can cache many other things. Okay, in this case, I do the global cache just for fun, but I also add this cache, okay? Probably recognize this already as a custom action. Okay, I could use some CLI command to upload it to S3, save it there, check hash of my files, and blah blah. But GitHub Actions does that for you. Okay, they probably save in Azure because Microsoft bought them, but you don't care. They do it for you. They save you the cache, and they save whatever you tell them. In this case, I just tell it save my node modules. And every time, and every other action after this one, okay, when it uses this, the cache marketplace action verifies that I have a cache with this key or hash. And if it exists, if I have a cache hit, just downloads it really fast. Okay, it's in the same call it VPC or whatever, the same network, so the downloads are very, very fast, and it saves time. And so we saw two ways of caching, and another one which is like the 2.5 is this. Sometimes the installation, the dependencies, create artifacts that are not in your inside your project. Okay, they are like system-dependent dependencies. For instance, you install on Windows, and it creates some files that are related to Windows, binaries that are related to Windows, or you install on Mac, and it installs something different, Linux, something else. So sometimes you need to specify a different path. In this case, I specify Cypress, because Cypress creates its own binaries that are responsible to control its browser. Okay, and the same way you can cache anything else. For instance, your custom build. And you build once. Okay, instead of adding this, you, I don't know, save your dist folder or wherever you save your artifacts, your build's artifacts, and it will just be there for every other job that is raised with this cache key. Okay. Now, why would we bother because of this picture? As you can see, this is the summary of our, let's say, CI. And you can see all the steps here, and you can see that the install dependencies took 0 seconds. Okay, and it saves quite a lot. Instead of taking, I don't know, sometimes 2 minutes, 3 minutes, on Mac 6 minutes, then this is what happened. And if you look at the code, let's go back to the code. I promised you conditionals, so you can even add conditionals to your steps. So here I have stated that the cache step has an ID, and then I can reference its output by steps, the step ID, outputs, and I know that this action emits a cache hit. If a cache hit was true, I just step over the installation step. But if I didn't have a cache hit, I need to install. Okay, this is how I can save time and actually run things conditionally in general in GitHub Actions. Where? Oh, okay, sorry. The question was, why would it take 6 minutes on Mac? As I mentioned, the Mac machines on GitHub Actions are very, very slow. Not my Mac. GitHub Actions Mac machine. Okay, it's all running in the cloud, the GitHub Actions machines. You can actually run GitHub Actions locally, but it's not part of this talk. I can send you the article I wrote about it at some point. Okay, any questions about caching? Because I think that's the most important part in optimization, at least for your boss. Cool. So one thing that can happen is that you push to your pull request, and then you remember, oh, I forgot to add semicolons, or I forgot to hit the tab instead of double space, and then you fix it, and then you push again. And then what you'll see is that 2 actions running at the same time, but one of them is running on an obsolete code. That's a waste. So the simple way to do that, to avoid that, is to use the concurrency property, which is at the same level as our trigger. And state a group, which is a kind of hash for the group of flows or actions that's running. And in this case, cancel in progress means that if I want to start something from that group, I check if there are running actions from that group, I stop them, and then I start the new one. Okay, and then I avoid two actions that are running, and one of them runs on an obsolete. Let's see if I have the example here. Yep. Okay, so this is actually in R. Okay, so we use it a lot, and it also helped us save a lot of GitHub Actions time. Actually, just these tips helped us save around 75% of our GitHub Actions time. Okay, there are, of course, optimizations you can use that are like micro optimizations or optimizations that fit your own project specifically. Yeah. Okay, so I mentioned the metrics. I think we have it. Okay, I mentioned the metrics as a way to reuse your code. Okay, like a for loop instead of hard coding all the options one after the other. But there are more ways to modularize your GitHub Actions, so they'll look as pretty as your own code. Okay, because you'd like to split your code into files. One of them is reusable actions. Okay, reusable actions are actually actions you can run as a job, but instead of writing the job's code, you write the job's code in a different file and just reuse this code in any other file that you want. So in this case, I created a reusable unit test and lean processes. And the difference between this and like a regular action is the trigger. And this trigger is the workflow call. That means that I can call it from a different workflow, and I can even send inputs to the reusable workflow. So you remember that I could send the cache yarn to the setup node action. So this is input for this action. That means that you can actually create your own jobs just like this one, just like you use this one. So how is it used? If you go down here, you see that my lint and test are just 2 lines now. Okay, and I just call them like this from my repository, the exact path, and the branch that the reusable workflows sit on. We'll soon understand why. I didn't use the with, but you know how to use that. I could just say with operating system and state the operating system in this way. Let's see. Okay, it works with everything we learned so far. So I mentioned the needs first, which is the dependency between jobs. So you can also use that. And this is the with, which sends the parameters to the job. The problem with it, okay, first of all, they run as jobs. So they're new machines that you raise. So you need to do the whole checkout and installation. You just get a new clean machine when they start. You can't use reusable jobs or reusable actions inside the reusable actions. Okay, this doesn't work yet. I hope they'll fix it. I remember when I found out about reusable jobs or actions, I was very happy. Yes, I can write them like functions and use them everywhere, but then it failed, and it took me a few hours to find out that it's not really working that way. And remember that branch I told you about? So you need to state the branch that the reusable action is running from, because if you state main, for instance, and you changed the reusable action on a different branch, and then you do pull request, it will run the main the old YAML from the main. It will ignore the new one. Okay, so there are a few ways around it. For instance, create a special branch just for reusable actions. You can do it in the same repository, and then you get the benefit of being able to reuse without worrying that you take it from main and you don't understand why the change isn't reflected. Or you can just change it just to test, and however you want. Just remember that the branch that is stated, wait a second, the branch that is stated, no, not here, sorry. Okay, the branch that is stated at the end of the file name, this one, from at, this is the name of the branch, is very important. It can save you a few minutes of frustration. So reusable actions are jobs. Jobs are new machines that we raise, but we saw that the checkout and the setup node are not new jobs, they are steps. And you can create them too. Okay, they are just JavaScript code that uses the GitHub Actions SDK, and it kind of looks like this. Okay, you use something, some path from your own repository, and this is how you send the let's see, this is how you send the parameters to the action. So this is how it looks. This is the E2E custom action, and you have action YAML, which is the definition of this action. This is the standard. Inside, you can state the input, just like we did for the reusable action or reusable job. You can state outputs, like we saw with the cache hit. So other following steps can use this output if you need it. And this is the definition. It runs on node 16, and it knows what files to go that actually runs the action. And the file is pretty straightforward JavaScript. Okay, it imports GitHub's SDK, and you can use it to get the input that the user sent. You can manipulate the input, do whatever you want with it. You can even push, fetch your repository, do whatever you can do in Git or GitHub, you can do here. But as I said when I started, if you get to the point that you need to write a custom action, you'll be wrong 95% of the time. Okay, but it can be a nice practice. I really enjoyed it when I started, even though a day after that I found out there are 20 other actions that do the same better. Well, we have a few minutes to talk about Docker. So far we talked about machines that GitHub Actions give you, but you can use your own Docker machine. Okay, I have no idea why would you would want to do that, but actually I can. But you can use it. Okay, let's say you created your own microservice, your own ultra service or whatever, and you want to just use it instead of setting it up. Okay, it's a long setup process. You created an image already, and you just want to use it. So this is how you do it. Okay, you create a machine, probably Ubuntu, and then you set the container as something from, this is from the public Docker Hub. Okay. This was actually our production until recently when we changed Drizzt to a more formal name. For instance, in our case, because we built visual regression system to our components, we found out that fonts, for instance, are different in every operating system. And more than that, every version of operating system works differently with fonts in different versions of browsers. So instead of building a huge matrix of browsers and operating systems, we just set up an image that is checking our components. So this is for to reduce our test flakiness, but you can just do it to save time and just raise a machine with your microservice or whatever. You can do even better. You probably recognize this kind of code, right? Services. Anyone? Docker, Compose, yeah. You can actually run services around your own machine. Let's say you raise the microservice, but it needs to speak to some test database, test Redis, or whatever. And I don't work at Redis, by the way. And you can do that. Okay, so it's very flexible and can do wonders. You sometimes need to work with external services. Okay, let's say you need to upload to S3 or to GCP in some way, or set up environment variables. Let's see, sorry, that's not what I wanted. Let's quickly see how to do that. So here we get, okay, under the settings, you have secrets and variables for the actions. And then you create a new secret, and you can create a new variable, and then you can use them by typing, I don't know why it didn't work, the link, but let's see if I can show you. Yep, got it. I don't actually know if we have it now because we changed our release. No, I don't have it here. But you get like a secrets property. So you get secrets dot the name of the secret that you set up, and it just translates. So it never push a secret to your repository. Okay? We still get messages from our CISO about a secret that we pushed accidentally a year ago, even though it's already an invalid secret. Okay, and we talked about the marketplace. So search it and see if you can even improve your team management. Okay, you can send messages to Slack. We did, for instance, on every release, we do 20 releases a day. On every release, we send a message on Slack, and management thinks we are doing a very good work. So don't tell them we don't. Okay, cool. So we talked about CICD, which is the main, I think the main usage of GitHub Actions, but we saw that we can automate a few more things, and we can, if you're working with Docker, I think you might have some things you'd like to try with this. I know I enjoyed it. And just try to automate, because what can go wrong with automation, you know? Okay. Thank you for listening. It was fun.
We have time for maybe one question. Yeah.
So hi, can the reusables be in a different repo, and can we use the tags instead of branches?
Can use the
Tags instead of branches when you call the reusables.
I didn't try tags, but it can be in a different repository. Yeah. You can use tags.
All right, thank you very much.
Thank you.